So here is our problem. We're given a string s and an integer k, and we have to return the length of the longest substring s that contains at most k distinct characters. So if this is our input string and k is 3, then the longest substring with 3 distinct characters would be defff, which is here, which has a length of 5. So what do we know here? Well, we only have to return an integer, not an array, which means we might not have to use an array to keep track of all the characters. We might just be able to get away with using only an integer. And the reason why we'd want to do this would be to save on space complexity. So if we don't need to use an array, then our space complexity might be able to be O1 instead of On. So that's the first thing, I think. Second thing is sliding window array or sliding window algorithm pattern sounds like a good first idea here. And actually, maybe I can just bring problem statement into here. So sliding window. So if I have this string, the sliding window is like I have a window that I want to slide through this array. So I can slowly expand it and say, well, how many characters are in this window? Well, there's one unique character. Now there are two unique characters, or it's still one unique character, sorry. Now there are two unique characters. Now there are three unique characters. So this is like the limit, right? So there are 3 in here. So now this is size 4. So I have aabc, which equals, length of 4. And this is not actual code. So if there were more C's, I could keep expanding and keep increasing this length, but because the next character is a D, what we see is that now there are 4 in here, so this is invalid. And so now what we have to do is start shrinking the window until there are 3 again. And so now we have a new window of length 3. And now we can expand. And now there are 4, which doesn't work. And now, again, shrink from the left, length 3. And now we can expand, and that is more than 3. Whew. So you can see these should be all of our, possibilities. And now when we keep expanding, we'll keep having new valid windows. And so this problem, or this one will end here with length 5, which is what the answer said, right? The answer should be 5. And so using sliding window, we are able to find this 5 length substring. So this, to me, reads as a very preliminary problem. So what's the time complexity? Okay, so yeah. This is initial thoughts. Sliding window. And that is time on. Sliding window has time on because we are touching every element twice. So, the way time complexity works is like, if you touch every element twice, that means like you're going to have like 2n or 3n or 4n, or like however many times you touch it, as long as it's not like n times n, right? Because now that's n squared, and that's like a double for loop, where you're going over every index n number of times. But if it's simply 2 or 3 or some other addition, then it all just simplifies down. So 2n is actually the same thing as on. And space complexity, well, I'm not sure we know what that is yet, because like I said above, with this, maybe we can get away without actually creating, expanding and shrinking an array, and maybe we can just use a single integer length. So we want to have variables. And actually, maybe I'm not so sure sliding window is on time. We expand, we contract. Yeah, sliding window should be a single pass on time thing. But it is sort of a double for loop. Okay. It's not a double for loop anyway. So longest substring with k distinct characters. So we got variables. What do we need for variables? Well, we're going to need length. Yeah, sliding window. So that's going to be like loop. We want to update window. We want to slide window to the right, right? Because that's what our algorithm did. We started here, slide window to the right. We want to check new max length if more than 3 characters in window. We want to shrink the window from the left. Maybe expand window right. And we want to return our max length. So something like this is what we're trying to work with. Now, how do we keep track of the amount of characters that are in this? And my thoughts are a hash map. Now, if I have a hash map is going to have a size of OK, because we are only going to allow 3 characters inside the hash map. So the hash map will have only 3 keys at any given time, or k keys at any given time. So we could say where k is the number of keys. So that's what I'm thinking right now. So we can go ahead and say, let max length equal negative infinity. So let's instantiate it to the smallest possible size. Okay, and actually, do I have any questions about the input? If this was in an interview, I would want to ask, could these letters be capitalized, right? Are there, I'm not sure what else matters. I think any character should be fine, but I'd want to maybe ask the max length or stuff like that. But this problem is fairly basic, and I don't think there are any like real constraints on the input that are gonna trick us up. And I don't have anyone to ask either, and this problem statement is very simple. So okay, so we can make a hash map. So we have our length and we have our hash map. Now to make a sliding window, I guess we're going to need left, it's going to equal 0. So right is equal to 0, right is less than s.length, and right plus plus. So the way the sliding window pattern works is you create a loop for the right side of the sliding window, and you have a variable for the left side. And inside here, so sliding window, loop, so expand window to the right. Let's fix up our pseudocode. So we're gonna wanna, say like let character equal, or let C equal to S of right. So let's get the current character, and I guess expand window to the right is sort of the same thing as the loop, but so actually what we want to do is like add character to hash map, and so we add it to the hash map. When it's in the hash map, so let's just how do we do this in JavaScript? If not C in frequency, then we say frequency C is equal to 0 and frequency C++. If not C in frequency. So we could do it like this, or we could have this in here. And I'm not exactly sure how to do this. So, okay. So we add it to the hash map. So we add A to the hash map, then we expand it again, add A to the hash map. Now there are two A's in the hash map, or the frequency of A is 2. And then we get B, so we get A is 2. And so like the way this looks is like A. So the first one we add it looks like this. Then it looks like this. Then for the third character, it looks like this. And then we get C1, right? So we keep adding to the hash map like this. And so what we want to do is get to the point where every time we add a character to the hash map, we can, okay, length is 0 actually. So what we can also do is just say max length plus plus, because we don't need an array. So every time we increase the window, we simply increase length, and every time we decrease the window, we decrease length. And we can just do len plus plus, and then we can say max len equals math.max max length len. So we increase length, and then we check to see if it's bigger. So we update max length separately, and we return max length down here. So length is free to increase and decrease, and max length will find the largest one of them. Now we have, if more than 3 characters are in the window, shrink the window. So what we can say is while left is less than s.length. I'm not sure. Yeah, this should be important. So while left is less than s.length, and I need to get the number of keys. While there are more, so I could say object.keys frequency. So this will get the number of keys in here. So once the number of keys is greater than k, the length is greater than k, that's when we want to be in here. And so what are we going to do when keys is greater than k? So when I get to this point, right, I got A2, B1, C1, D1. Now there are 4 keys in here. 4 is greater than 3, so what are we going to do about it? We want to start shrinking the window from the left. So what we want to say is frequency, frequency of s left, negative negative, if frequency, and instead of s left, C2 is this. If frequency C2 is less than or equal to 0, then we'll delete frequency C2. So we'll subtract the keys. So A, we'll subtract it and get to 1, subtract it again and we get to 0, and when it equals 0, then we delete it out of the hash map. So that's what we want to do here. And we also then need to increase left. And we need to decrease length. Length minus minus. So, okay. I'm checking max length in the middle here, which kind of worries me. I think I want to check for max length down here, but I'm a bit confused. So let me think for a second. We add the character to the map, A, increase length by 1, frequency as well, then it's not greater than 3, so now we check max length. Then we get 2, so max length is 2, it's not greater than 3, now it's 3, it's not greater than 3, now it's 4, and so we don't want to set it to 4. We don't want to set max length to 4 because it's not 4. We want to set it after we've shrunk it down, and that's what we found up here. Okay, so this actually looks good to me. Now, how do I open up a new terminal? Okay, I'm gonna run it, and I got a freaking error, because that is uncommented. And okay, there we go. We got the answer 5. So this algorithm works. And it works in ON time complexity and ON space complexity. So, once again, let's summarize what's going on here. And, maybe it'd be helpful to run the array or throw, console log statements in. But so what happens is we have max length, which is sort of our master length value, and then we have length, which is, or len, which is our temporary length value. So this one's free to go up and down, and max length will, we'll use that to record the largest value of len that we find. Frequency is our hash map. And so we use the hash map to record the character frequency. Left is the left side of our window, right is the right side of our window. So we expand our window to the right, and we add each character into our hash map. We increase the size of length, and then we check to see if max length is larger, if we have a new max length. Now, in between here, what we do is we check to see if our hash map has more keys than k. So if we get 4 keys in here, like A, B, C, D, that's 4 keys. And so what we want to do is shrink the window first. So we subtract frequency from the hash map, so that would be like this. And if we do that twice, then we get 1, 0, then we delete it from the hash map. We increase left each time, which moves the left side of our window over, and we subtract from length, and then we add to length. So really basic sliding window problem, and good luck with your future interviews.